right, before I explain all these questions, I just wanted to mention that I have updated last week's practical with additional questions, which may help you with your assignment 3 question. Okay, questions. I was intended to give assignment help today as well, if I have time, but let me go through these questions first. Okay. The first question is about Taylor series approximation. Okay. Find Taylor series approximation for ln 1 plus x squared about x equals 0. Check if the series is convergent or not. And then you can give a general formula for Taylor series approximations. In exam, you don't need Mathematica, but here I have used Mathematica just to check my work. Okay. All right. Let's start. I need to share my iPad screen. And for the rest of the questions, I wouldn't show the questions, but use my iPad to compute the solutions. The second question is about finding gradient and approximating the function fx, where this has 2 variables with Taylor series approximation. The third question is about finding determinant of a 3 by 3 matrix. Fourth question is integration. You will need integration by parts. Fifth question is a little bit long, but you must have done something like this in your assignment, but this is a different version. Okay. Let's start with question 1. Okay, how would we proceed? Okay, just remember that if the expansion is around x equals 0, then it's a Maclaurin series. And we can get from your lecture notes, we can get that Maclaurin series as sum of starting from n equals 0 to infinity of the derivative of f with respect to x, and then evaluated at x equals 0 times x to the power n divided by n factorial. That's in general. So we could start with, let's say, a simpler function ln of 1 plus x, which is the first derivative is when n is 0, that is f of 0, which is 0. And when the first derivative is 1 over 1 plus x, and evaluated at x equals 0, which is 1. And second derivative is 1 minus 1 over 1 plus x squared, evaluated at x equals 0, which is minus 1. And it goes on like this. After computation of f-6, like the sixth derivative, I got it as minus 120. Which in compact notation is minus 1 to the power n plus 1 and times n minus 1 factorial divided by x plus 1 to the power n, which can be simplified to yeah, how did I get that? Yeah, at x equals 0, which can be simplified to this part here. And that means when the function is ln 1 plus x, we get a nice formula here. for the summation, but then what I did was I replaced x with x squared, which gave me this one here. Same thing. So instead of x, put x squared, and then expanding this, we get x squared minus x to the power 4 over 2 plus x to the power 6 over 3 minus x to the power 8 over 4, 8 over 4, which is what I got from Mathematica as well. All right, any question for that part? Any question? Okay, the next one question is to test for convergence. We could use ratio test. I think so, Ashish. We can replace x with any function of x. Yeah, that's a good question. The short answer is at the moment, I assume it can be, but let me think about it. But for this case, it definitely works. Okay. And for the sum, using ratio test, let L be the limit. If it is ratio test, it is a n, the absolute value of a n plus 1 divided by a n. Then it converges if the limit is less than 1, or diverges if it's more than 1. If it's equal to 1, when it's inconclusive. Okay, so what I did was I computed the ratios a n plus 1 divided by a n, which simplifies to, yeah, I forgot. Limit as n tends to infinity, which gave me n times x squared divided by x squared, and and yeah, probably this would be if x squared is, if converges for x squared, absolute value of x squared less than 1, which means we could, if we remove the absolute value, which is x squared, square root of x squared less than square root of 1, which implies that the absolute value of x is less than 1. Okay, so the series converges for x between -1 and +1. Okay, so that's the first question. The second question I've asked is gradient computation. So you are given the function let me try this. X is x1, x2, which is x1 plus I for x2 takes x1. Okay, the first part is find the gradient of fx. Okay. What does that mean? How do you compute that? Yeah, partial derivatives. Okay, that would be equal to yeah, with respect to x1 and x2. So you differentiate f of x with respect to x1 first, and then take f of x with x2, which would be equal to, okay, f with respect to x1. What is that? What's that? Yeah, that is 1 plus the derivative of e power something is e power something x2 minus x1 multiplied by the derivative of the power of exponential, which is -1 with respect to 1. And the second component is with respect to x2. That's 0, so it's e power x2 minus x1 multiplied by +1 this time, which is equal to 1 take for x2 minus x1, x2 minus x1. All right. Okay, that's the partial derivatives. Okay, we got two components. How do we use this to find the Taylor series approximation of fx around a given point x equals 1, 2, up to order 1. That means just one of them, okay? You don't need other derivative, okay? This just the first partial derivative. Okay, what would be the what's in general Taylor series approximation? Equals what? So we are going to use f of, the first one is f of around x equals 1, 2. So that means x1 is 1, x2 is 2. So f of 1, 2 plus f of 1, 2 x minus 1, 2. Okay, so that's what we are going to do. So you, for the first one, you would sub for x1 equals 1 and x2 equals 2 in the formula, and I got that is 3.71828. $3.718 183 plus, then we got the derivative, that is you would compute this one at 1, 2, okay, which means 1 minus e to the power x2 is 2, so it's 2 minus 1. And this is e to the power 2 minus 1 as well. Okay. You could do that, which is equal to, when I computed that, I got it as, the first one is minus 1.7183. Yeah, let me check. 1.7183. This is 2.7183. 2.7183. Okay, and then you got x is x1 x2 minus 1 2, which is equal to 3.7183 minus 1.7183, x1 take 1 plus 2.7183. The second is x2 take 2. Okay, makes sense? Any questions? No questions? Let's have a look at the third question. Determinant of a 3 by 3 matrix. Okay. So you got A equals 7 0 minus 3, 2 3 4, 1 minus 1 minus 2. How do you find the determinant of A? Which you can say that's also the notation. Any ideas? This is a 3 by 3 matrix. Which method would you be using? Yeah, Ashish, you're right. Cofactors. How do you find cofactors? Okay, you expand this along any row or any column. Okay, let me take row 1. Okay, expand along row 1. Expand along row 1, which would be cofactor method says, so if you have, these are the ith components, so 1 2 3, the jth is a column 1 2 3, okay, yeah, minus 1 to the power I plus j. So if I use the first row, I got the first cofactor is minus 1 to the power row 1 plus column 1. The value is 7 here, times the determinant of, let me check. Let me use the symbol of, ignore the first row, first column, that is 3 4 -1 -2 plus the second cofactor is -1. We are still in row 1, but column 2. The value here is 2. So 2, and then the determinant of, ignore the first row and the second column. You got what is a 0, -3, and -1, -2, and plus -1. This time it's row 1, column 3. So that's row 1 plus column 3. The value is 1. So that's 1. And determinant of 0 -3, 3, 4. 3, 4, which is equal to -1 to the power 2, which is 1. So that's 7. Determinant of, this is a 2 by 2 matrix. So you would do A, B, C, D. Determinant would be A times D minus B times C. So using that method, we got 3 times -2, which is -6, minus -4, and -1 to the power 3 would be -1 times 2, which is 2, so -2. And the determinant of this metric will be 0, 0 times -2, which is 0, minus -3 times -1, which is 3, plus, that's 1, 0 minus, -9. Let's see if this is the answer. I got 7. -6 plus 4, -2, -3, plus 1, plus 9, which is 7, minus, plus 9. 1. Is that the answer? So I got a 1 here. Okay, please do check. I don't think I've made a mistake. Yeah. Any question? Any questions? No. Okay, the second question, third question is about integration. Sorry, that's the fourth. E power x sine x dx. Okay. How would you approach this question? By parts. Very good. Do you remember the by parts formula? U dv is equal to minus v du. Okay. Okay, how would you, yeah? Okay, which one, you got e to the power x and sine x. Which one would you use for u? Which one would you use for dv? E to the power x can be v. Yeah. Yeah, these two functions are like not that simple. It keeps repeating itself. So you could choose either one. Let's try u is e to the power x. Let's try u equals e to the power x. Then we got du equals e to the power x dx. And if I say dv equals sine x, and v would be integral of sine x dx. What is that? What's integral of sine x? Minus cos x, thanks, Ashish. Minus cos x. And putting this together, we get sine x dx is equal to u times v, which is e to the power x times v is minus cos x, so minus cos x, and minus v is minus cos x, du is e to the power x, so that would be minus cos x e to the power x dx, which is minus e to the power x cos x plus dx. All right. Now what do we do? How would you proceed again? Using again by parts, Ashish, thank you. Let u be again for this part. Let u be again equal x, so du is equal x dx, and dv is cos x, so v is integral of cos x dx, which is equal to what? Sin x. Okay, so that means we can say that's equal to minus x cos x, plus this time we have to use the by parts. It's u times v, so that's e to the power x sin x minus v du. V is sin x. Du is e to the power x dx. Okay, that gives us minus e to the power x cos x plus e to the power x sin x minus Okay, are we getting anywhere? Remember, your left-hand side is equal x sin x dx. Okay. How would we proceed? Yeah, so you recognize that that's the same. So what we are going to do is collect the like terms. That means 2 times equal x. Dx is equal to e for x sin x minus e for x cos x. That's the like, collecting the like terms, which gives us x sin x dx is equal to divide by 2, so that's half e for x sin x minus cos x. All right. Any questions? Okay, the next one is about truncated normal. Okay, I forgot to mention that. A recursive formula for the moments of truncated normal distribution. Truncated because this is evaluated at 2 limits, a and b. Okay. What's your thoughts about this? In the assignment, it's not truncated, it's the usual normal, but this is for truncated normals. The application of truncated normals are like can be applied to various situations. On top of my head, I can't remember, but let's derive this. Okay. Moments are like used to find the expected value and variances. So in general, if you have x as normal distributed, mu is with mean mu and a variance mean mu, variance sigma squared. the kth moment of the truncated normal distribution, distributed where A and X is defined for A and B. Okay, where A and B is in, plus infinity, A less than or equal to A less than B. Okay. We need to show that the kth moment is given by this horrible recursive formula where this function is the PDF. This is the PDF of you. Okay, that's the PDF of standard normal distribution. And this is also standard normal distribution. And this is the CDF of standard normal. All right. So how are we going to show this one? And also the values of M starting with M -1 is 0, M0 is 1. All right. So the definition of standard normal random variable is this part here. Its mean is 0. Variance is 1. Okay. That's the standard normal mean and variance. The PDF is in general given by this PDF of standard normal. Okay. And that's the CDF, cumulative distributive function of standard normal. Okay. We have to use those two. Okay, I started with defining, let N0 be the probability that X is between A and B, where X is in general normal with mean mu and sigma squared, variance is sigma squared. That means this really means is you would integrate with from A and B your standard normal f of x dx, which is equal to AB 1 over square root of 2 pi sigma squared e to the power minus half x minus mu squared over sigma squared dx, okay, which can be written as the CDF, which can be evaluated as the CDF of which is B minus mu over sigma minus A minus mu over sigma. Okay, that's what I've defined here. Okay, and then mk times n0 would be equal to x to the power k, which is the expected value of mk, times n0, which is the CDF given here. Okay, that's equal to x to the power k, and then this is really the CDF of standard normal, a scale by sigma, okay, which is equal to up. Now this is rearranging x to the power k and sigma. X to the power k can be written as x to the power k minus 1 times x. And sigma, for sigma I've written as sigma over sigma, which is 1 divided by sigma, which is like quite complex idea, but I really need to get to that bottom part. So that can be rearranged as x to the power k minus 1. And this sigma squared is here. And that's x to the power, this x goes here, okay? And the whole idea behind splitting this is to be able to write down something in terms of the standard normal, okay? Which again, splitting this is that part, and removing the bracket. Okay, I got these two integrals. Okay, that's the first part, that's the second part. And for the first part and second part, use for the second part, first part, use by parts. Okay. Which gave me this whole thing here. And recognizing that, rearranging that this integral here is really the standard. This part really is the standard normal. Okay. So I got up to here, and recognizing that n0 is the characteristic function, which I defined here, okay, gives us the result. This is very complex, but this is something that you could do, all right? And I wouldn't imagine you would be asked to prove this, but you might have to use this recursive formula to derive the moments. For example, using that formula, you got M1 is mu sigma phi and M2. You might be able to you could be asked to find out these moments. The second moment, which is mu squared plus sigma squared minus sigma mu plus b 5. And this would be minus divide by, so this is just using that formula. This is A minus mu over sigma. And then you could go on like that. Okay. Any questions? You could, it's really you need time to prove that recursive formula, but you can use the recursive formula to derive the first and second moments. First moment is the expected value. Okay, second moment, you will use the second moment to compute the variance. All right, any questions? Is there, like, how are you doing with your assignment? Have you finished it? Is there any particular question that was difficult for you? Let me stop the recording because it's 50.